Hello everyone, my name is Angie Pogi, and in this video I'm going to talk about correlation. The correlation coefficient is used to quantify the association between two continuous variables that are linearly related. The correlation coefficient is a dimensionless quantity that is independent of the units of x and y and ranges between -1 and 1. A correlation coefficient of 0 implies independence of random variables. A correlation coefficient close to 1 implies neatly perfect positive dependence with large values of x corresponding to large values of y, and also small values of x corresponding to small values of y. A perfect negative dependence will have a correlation coefficient close to -1 with large values of x corresponding to small values of y, and vice versa. The first step to determine whether or not two variables have a linear relationship is to create a scatter plot. Each point indicates the coordinates for independent and dependent variables. In our dataset, we have a couple of continuous variables. Let's try to determine the correlation between age and BMI. As a reminder, to do a scatter plot, in StatCrunch, click on Graph, Scatter Plot, and select your x or independent variable and your dependent variable on y. StatCrunch gives you the options to group by a categorical variable, such as gender, and to overlay a polynomial order. From your algebra or pre-calculus class, you might remember that the linear equation has a polynomial order of 1. Our final step is to click on Compute. Even though it looks like a random relationship, you can see a slight linear negative relationship for both genders. Let's compute the correlation coefficients to confirm. Click on Stat, Summary Statistics, Correlation. Select the two columns, age and BMI, and group by gender. Then click on Compute. The result is -0.17 for males, but for females it is -0.51, which implies a moderate negative relationship between age and BMI. Therefore, we conclude that in the sample of 100 MI patients, as age increases, BMI tends to decrease for females.